Today we're talking about scientific notation, which is extremely useful if you're using really big or really small numbers. And essentially, scientific notation involves floating point numbers, either float or double. And the way you specify it is you specify a number, I'm saying here between 0.11 and 9.99, but in fact those are somewhat arbitrary values. It's just a floating point number that's less than 10. And then you have the key letter E, capital E, which stands for exponent. And in the case of things multiplied by 10 to a positive exponent, you have a plus. You could have a minus instead of a plus, which would give you a negative exponent, which would start giving you smaller and smaller numbers like .001 and so on. But in the case of what we're discussing, we use a positive exponent and then a power of 10 multiplier. So if you had 9.99 E plus 2, that would be 9.99 times 10 to the second power, or 9.99 times 100. And the test program we're using to illustrate this is a console application. And it somewhat bothers me that I didn't put public here, so I'm going to put public. And we have a double data type called a variable called W, and then I say W equals 4.37 E plus 0, and that would be times 10 to the 0, and anything times 10 to the 0 power is times 1, so that'll essentially be 4.37. And then the next one is 4.37 times 10 to the 1 exponent, which will be times 10, because any number to a 1 exponent is itself. And the next one is 2, which was 10 to the 2, or 100. And then I go into the standard nomenclature for things like E plus 3 is times 10 to the 3, or 1,000, so that would be a K. E plus 6 would be 10 to the 6, so that would be a meg. E plus 9 would be 10 to the 9, so that would be a gig. And E plus 12 would be 10 to the 12, so that would, I think, be a ter. It's like a terabyte. I think ter is the abbreviation for that. But you can see where if you're specifying a huge number, this is a useful notation. You don't have to write something out that's a million lines long. And in fact, when we do the console write, we do write it out that's a million characters long. We use the :n notation, which is numeric, which basically puts a decimal point and 2 decimal figures after it, generally, and then puts commas in between the every 3 places, you know, the standard way of writing a number in a more clear way. So if we save this program and then do a compile on it, do a CSC and then SCI note.cs, and then we do a directory, we see we've created an exe file. So if we run this exe file by typing SCI note, you see we get the notation we're specifying, which I actually should have changed this to 4.37. I used to be 1.7. And if it's to the 0 power, we get 4.37. If it's to the 1 power, we get 43.7. If it's to the 2 power times 100, we get 437. And then if it's to the k power, we get 4 comma 370. To the 6 power we get 4,370,000. To the gig power we get 4,370,000, and to the tera power we get 4,370,000,000. Well, maybe I'll up arrow to go through previous commands I did here. Get to the edit it with Notepad, and maybe I'll change all these to 4.37. Whoops, I'm not having a good day. Alright, I changed all those at super speed. And another useful notation, N is for numeric, which is every 3 characters separated by commas, and then a dot and 2 decimal places generally. Another useful notation is C, which is for currency. So if I do, I highlight that and right click and press copy, and then go down a line and right click and press paste, and then change this to a C, and then do a file save and exit out. And then if I move press the down arrow to bring up previous commands, I'll get to where I did a compile of this. Press enter, and then go down to where I ran it and press enter. You see the :C format gives us currency. So this is $4,370,000,000. The exact amount I hope to make next year. Well, I hope you enjoyed this video and learned a lot, and don't forget to subscribe.